future circular collider?
Okay, picture this. A tunnel. Huge tunnel, like 100 kilometers around, buried deep underground, right? And inside this tunnel, you've got these tiny particles whizzing around at almost the speed of light, guided by the most powerful magnets ever created. And that, in a nutshell, is the FCC, a proposed successor to the Large Hadron Collider, aiming to smash particles together at energies that dwarf anything we can achieve today.
Whoa, okay, that paints a pretty vivid picture. But you said something about energies we can't achieve today. So why is that so important? What's the big deal about higher energies?
Well, think of it like this. Smashing particles together. It's kind of like unwrapping a present, right? The higher the energy, the smaller the pieces you can break that present into, and the more likely you are to find something really surprising inside.
Ah, okay, so we're basically trying to smash open the universe's tiniest secrets.
You got it.
But why do we need a whole new collider for this?
Right.
Why not just upgrade the LHC?
Well, it's not quite as simple as that. The LHC is a phenomenal machine, don't get me wrong, but it's getting close to its limit. To take that next leap, we need a new collider, one that's built from scratch with all the latest tech.
Okay, so it's like trading in your old reliable car for a supersonic jet.
Yeah, something like that.
But you mentioned something about this not just being one collider. There's talk about two different parts, right?
That's right. There are two main phases to the FCC. First, we have the FCC-ee, the Electron-Positron Collider. Think of it as a master watchmaker, carefully examining each tiny gear.
Okay, I like that analogy. So what kind of insights will this watchmaker uncover?
Well, the FCC will be a real game changer when it comes to studying particles like the Higgs boson. We'll be able to measure its properties with incredible accuracy, potentially even uncovering clues about the very early universe.
Wow, so we're talking about moments after the Big Bang.
Yeah, potentially.
That's pretty incredible. But you mentioned a second phase.
Yes, so after the FCC has run its course, we move on to the FCC-hh, the Hadron Collider. Now this one is all about brute force.
Ooh. All right, bring on the brute force. Tell me more. What makes this one so special?
While the FCC-ee is all about precision, the FCC-hh is like a powerhouse. It's capable of smashing protons together at a staggering 100 TeV. That's 7 times more powerful than the LHC.
Okay, my mind is officially blown. 7 times more powerful.
Yeah, it opens up a whole new realm of possibilities.
Can you even give me a sense of scale here? Like, what does that kind of energy actually mean in practical terms?
Okay, well, the LHC, right, that's what discovered the Higgs boson, this particle that's so fundamental to our understanding of the universe. They call it the God particle. Well, the FCC-hh could potentially create particles hundreds of times heavier than the Higgs.
So we're talking about discovering, like, a whole new continent on the map of particle physics.
Exactly. We could uncover particles so massive they haven't been seen since the universe was just fractions of a second old.
Okay, I'm officially hooked. But let's be realistic. When can we actually expect to see this science fiction dream become a reality?
Well, from what I've seen, 2025 is a big year. That's when the feasibility study wraps up. And the big decision gets made. Do we give the FCC the green light or not?
So we're on the edge of our seats then. But assuming everything goes smoothly, what kind of timeline are we looking at here?
If everything goes according to plan, construction could begin in the 2030s. And by the mid-2040s, the FCC-ee could start its run, potentially for 15 years of meticulous measurements. Then in the 2070s...
Hold on, 2070s, this isn't just a project, it's a legacy.
It really is. The FCC-hh is set to take over in the 2070s, pushing the boundaries of physics for another 25 years.
Wow, we're talking about a multi-generational endeavor here. But to create something this extraordinary, you need more than just big dreams and a long timeline. You need the right tools for the job. So tell me, what kind of mind-bending tech is going to make all of this possible?
Well, that's where the ingenuity of human engineering really shines. To start with, we'll be using 16 Tesla superconducting magnets.
16 Tesla. Now, I know you can't just throw out a number like that and expect everyone to grasp the significance. Just how powerful are we talking here?
So think about the strongest magnet you've ever encountered, like in an MRI machine. Those are about 1.5 Tesla. Now multiply that by 10. And you're in the realm of the FCC magnets.
Okay, I'm equal parts terrified and impressed. What other technological marvels are we looking at?
Well, controlling particle beams at those speeds, that's a monumental task. We're talking about beams traveling almost as fast as light, so even the slightest wobble could be disastrous.
Sounds like one heck of a balancing act.
It is, and then there's the cryogenics. We have to keep those powerful magnets at almost absolute zero. That's minus 273.15 degrees Celsius colder than outer space, and we need to maintain that temperature over a 100-kilometer tunnel.
Okay, that's just mind-boggling. It's hard to even fathom the sheer scale and complexity of something like that. But once we've got all of this incredible technology in place, how do we actually make sense of what happens when these particles collide?
That's where the detectors come in. Imagine digital cameras capable of capturing billions of frames per second, each frame revealing the fleeting traces of particles born from these high-energy collisions. These detectors will be more sensitive and sophisticated than anything we've ever built before.
It's like trying to capture the first moments of the universe's creation.
It really is. And to build these detectors, to construct this massive underground marvel, to even dream of achieving something this grand, it requires something truly special, something that speaks to the very heart of what it means to be human.
You're talking about collaboration, right? Because I noticed several of the articles you shared really emphasize the international partnerships at the heart of the FCC.
Absolutely. The FCC isn't a European project or an American one. It's a global endeavor. Thousands of scientists, engineers, technicians from all over the world, all working together towards a common goal.
It's like the United Nations of Science.
Yeah.
A shining example of what we can accomplish when we put our differences aside and work together.
Exactly. And that's what makes the FCC so inspiring, you know? It shows that even in a world that's often divided, the pursuit of knowledge can bring us together.
So we've covered the what's and the how of the FCC. The mind-blowing technology, the global collaboration, the sheer scale of the ambition. But now, let's get to the heart of the matter, the why.
You're right. The FCC isn't just about building bigger machines or breaking energy records. It's about answering some of the deepest questions humanity has ever asked. Questions about the origin of the universe, the nature of matter, the very fabric of reality itself.
Questions that have puzzled philosophers and scientists for centuries. And the FCC might just hold the key to unlocking those answers. But we'll have to wait for part 2 to dive into those mysteries.
Stay tuned.
Welcome back to our deep dive into the future circular collider, where we're peeling back the layers of reality to get to the bottom of some of the universe's biggest mysteries.
Yeah, we're picking up right where we left off with those big, fundamental questions, the ones that have driven scientists and philosophers for centuries.
You mentioned the origin of the universe, the nature of matter. Those are some pretty heavy topics. Where do we even begin?
Well, let's start with one of the most profound mysteries in modern physics, the existence of dark matter. This invisible stuff that makes up like 85% of the matter in the universe, and we have absolutely no idea what it's made of.
It's like the cosmic elephant in the room.
Yeah.
We know it's there, but we can't see it, can't touch it. Actually, one of the papers you shared by Catherine Fries, she uses a great analogy. She compares it to a snow globe. We see the snowflakes, the visible matter swirling around, but there's this unseen stuff, the water, that's actually driving all the motion.
Yeah, that's a great way to put it. That water is the dark matter, holding galaxies together with its gravity, but staying completely hidden from our telescopes.
So how can the FCC help us understand this elusive stuff? Can it finally shine a light on this cosmic mystery?
Well, that's certainly the hope. One possibility is that the FCC could actually create dark matter particles directly. Imagine two protons smashing together at incredible speeds, like a cosmic car crash, and out of that wreckage, new particles are born. And some of those, just maybe, could be dark matter particles.
So we're talking about searching for a needle in a haystack here.
More like searching for a ghost in a graveyard, actually. You see, dark matter particles interact very weakly with ordinary matter, so they would just pass right through the detectors, leaving almost no trace.
So how would we even know if we'd found them?
By looking for what's missing. Think about it. Imagine you've got a scale perfectly balanced, and suddenly one side gets lighter. You know something's gone, even if you can't see what it was. It's the same principle here. We would look for missing energy and momentum in the collisions. That would be our clue that something unseen is at play.
That's really fascinating. So it's not just about seeing something new, it's about noticing what's not there.
Exactly.
But what if we don't find any dark matter particles? Would that mean the FCC was a failure?
Not at all. Even if we don't find what we're expecting, the data from the FCC would still be incredibly valuable. It would help us narrow down the possibilities, guide future research.
Just like eliminating suspects in a cosmic whodunit.
That's a great way to think about it. Every experiment, whether it confirms or refutes our theories, brings us one step closer to understanding the universe.
Speaking of cosmic mysteries, you also mentioned antimatter. I remember reading an article about how the universe should have equal amounts of matter and antimatter. But something happened. Something tipped the scales. Where did all the antimatter go?
That's the million-dollar question. You see, antimatter is like matter's mirror image. For every particle of matter, there's an antiparticle with the opposite charge. And when matter and antimatter meet, they annihilate each other. releasing a burst of pure energy.
So if matter and antimatter were created in equal amounts during the Big Bang, should they have just canceled each other out, leaving nothing but energy?
Precisely. But somehow, there was this tiny, tiny excess of matter that survived. And that's what led to the universe we see today.
Okay, but what caused this cosmic imbalance? Is the FCC going to give us an answer to that?
Well, the FCC could help us find answers by studying the properties of particles and antiparticles with incredible precision. One possibility is that there are these subtle differences between matter and antimatter, differences so small we haven't been able to detect them yet.
Like a tiny crack in a seemingly perfect mirror.
Exactly. And the FCC, with its incredible precision, could be the tool that finally reveals those cracks.
I'm starting to see how the FCC is like this giant magnifying glass, allowing us to zoom in on the universe's tiniest secrets. But let's shift gears for a second. You mentioned earlier that the FCC's impact goes beyond particle physics. What did you mean by that?
Well, the technologies we develop for the FCC, they often have these ripple effects in other fields, leading to some pretty unexpected breakthroughs.
Can you give me some concrete examples? You highlighted a paper in your research about the FCC's potential for medical imaging.
Ah, yes. Well, those powerful magnets we were talking about, they could revolutionize medical imaging. Imagine MRI machines that could produce images so detailed. Doctors could detect tumors at their earliest stages.
That's amazing, like having X-ray vision, but on a microscopic level.
And the benefits go beyond just diagnostics. Those superconducting magnets could also be used in proton therapy, which is a highly targeted form of radiation therapy. It delivers high doses of radiation directly to tumors, while minimizing damage to surrounding healthy tissues.
So the FCC could lead to breakthroughs in both diagnosing and treating cancer.
It's certainly a possibility, and that's just one example. The advancements in computing and data analysis that we'll need for the FCC, those will have applications in all sorts of fields, from climate modeling to financial forecasting.
It's like a technological chain reaction. Innovations in one field sparking breakthroughs in others.
Exactly. The FCC is a catalyst for progress, pushing the boundaries of what's possible, and inspiring new discoveries in all sorts of unexpected places.
You know, I'm starting to really grasp the scope of this project. It's not just about particle physics. It's about human ingenuity, international collaboration, the potential to change the world in ways we can't even imagine. But let's be honest, a project this ambitious, it must come with its own set of challenges, right?
Oh, absolutely. Building something this massive, this complex, it's no walk in the park.
What are some of the biggest hurdles you foresee?
Well, for starters, there's the engineering challenge of excavating a tunnel that's 100 kilometers in circumference. That's like digging a subway line around a major city.
Wow, yeah, the scale of this is really starting to sink in.
And it's not just about digging a hole in the ground. We need to make sure that tunnel is stable, that it's safe, that it can withstand the incredible forces generated by those particle beams.
And I imagine there are also environmental concerns to consider.
Absolutely. Sustainability is a key factor in every aspect of the FCC project. We need to minimize the environmental impact of the construction and the operation, everything from energy consumption to waste management.
So it's not just about pushing the boundaries of science, it's about doing it responsibly.
Exactly. The FCC isn't just a scientific endeavor, it's a human one. And we have a responsibility to make sure that our pursuit of knowledge doesn't come at the expense of our planet or future generations.
That's a powerful statement. So we've got the engineering challenges, the environmental considerations, and of course the financial aspect. You mentioned earlier that the FCC could cost tens of billions of euros.
That's right. It's a significant investment, no doubt, and it requires a long-term commitment from all the participating countries. But it's important to remember that the potential benefits are enormous.
You're talking about the scientific breakthroughs, the technological advancements, the potential to solve some of the world's biggest challenges.
Exactly. The FCC is an investment in the future, not just for science, but for humanity. It's a bet on human ingenuity, on our ability to overcome the greatest challenges we face.
I'm starting to see why this project is so captivating. It's not just about smashing particles. It's about exploring the unknown, pushing the limits of what's possible, and leaving a legacy for generations to come.
And those are the questions we'll be diving into in Part 3, when we explore the philosophical implications of the FCC.
Stay tuned, because things are about to get deep. And we're back for the final part of our deep dive into the future circular collider. It's been quite a journey, hasn't it? We've gone from the nitty-gritty of particle physics to the mind-boggling scale of this whole project.
Yeah, it's really remarkable what humans can dream up when we set our minds to it.
But now, as we wrap things up, I want to shift gears a bit. and get into something a little more, well, philosophical.
The big questions.
Exactly, because the FCC isn't just about data points and new particles, right? It's about something much deeper, something that speaks to what it means to be human in the first place.
You're talking about our innate curiosity, that drive to explore the unknown.
Exactly. I mean, think about it for a second. We're this species that evolved on this tiny little planet orbiting an average star in this vast, mind-bogglingly huge universe. And yet, here we are, trying to understand it all, to map its hidden dimensions, to unravel its deepest secrets.
It's almost like we're hardwired for it, this cosmic imperative to make sense of the world around us.
And the FCC, in a way, is a perfect embodiment of that. It's a testament to human ingenuity, to our collective ambition, to reach beyond what we know and explore the vast unknown.
It's like we're standing on the shoulders of giants, you know? All those scientists, philosophers, dreamers who came before us, the ones who dared to ask the big questions, to imagine a world where knowledge knows no bounds.
And now, with the FCC, we have this incredible opportunity to take that next giant leap forward, to push the boundaries of human understanding further than ever before.
And who knows what we might find out there? What if the FCC reveals a universe even stranger and more wondrous than we can even imagine?
What if it unlocks secrets that completely reshape our understanding of reality?
It's a thrilling prospect, isn't it?
It really is. But let's be realistic for a moment, right? There's always a chance we won't find what we're looking for. What if, after all this time, all this effort, all this investment, the universe just doesn't give up its secrets?
That's always a possibility. But even if we don't get the answers we're hoping for, the journey itself will have been invaluable.
What do you mean?
Just think about the process of building the FCC, pushing the limits of technology, collaborating on a global scale. That alone is bound to lead to new insights, new discoveries, new ways of thinking.
So it's not just about the destination, it's about the journey itself.
Exactly. And sometimes, the most profound discoveries come from unexpected places. Those serendipitous moments of insight that happen when you venture off the beaten path.
There's a quote by Marie Curie that comes to mind. She said, "Nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less."
That's beautiful. It really captures the spirit of scientific inquiry, doesn't it?
It does. The more we understand about the universe, the less we have to fear.
And the FCC, with its potential to illuminate some of those deepest mysteries, could be a powerful tool in that quest for understanding.
I think you're absolutely right. So as we wrap up our deep dive into the future circular collider, I want to leave you with this thought. What if this project leads us to a universe even more amazing than we can imagine? What if it helps us solve some of humanity's biggest challenges? The possibilities are truly endless, and the journey of discovery is just beginning.